So question 6 says, let's fit the same models in log form. Now there's a little wrinkle here. It explains. Let's open the data set. So there's the data set that where you're doing this for homework that you would actually see. And one of the things that you'll see is that in the column for the quantity of the expenditure on meat, there are some zeros. But the specification called for log-log models. Log of the dependent variable, log of the independent variable. So you're going to have some observations where you're trying to take the log of 0. Can you do that? No. So what are you going to do? Fit everything. That's and what's the idea behind least squares? Between the square difference between 1 and 1. Just in general. Don't worry about it. The two variables. Some of the square differences between the observed data point and the fitted data point. What's the log of 1? What's the log of 2? Smaller than 2. Remember, the log looks like that, right? And so when you take the logs of your data, it pushes things out, flattens it down. So that if there are wide variations in your data and you want to smooth things out a little bit, because you're trying to tell an interesting story about your data and all that noise in the data is kind of disrupting the story a little bit, you can kind of, it's like when your mother was young, she would iron her hair before going out on a Friday night or Saturday night to straighten it. You never told me that? What? So this is kind of what you're doing with your data. You're getting out an ironing board and an iron. And by taking the logs and smoothing it out, you're taking the wave and the curl out. Barack Obama's mother would iron her hair. So the reason I asked, what are we going to do with these zeros? It was just suggested that we'll add a small number to them. Well, the log of 1 is 0. The log of 2 is a number that's between 0 and 2, like 1.1 or something. And as you go along, as you increase the size of x, the incremental change in the log of x gets smaller and smaller and smaller. So our intuition suggests that as we go the other way, the difference in the log of x is going to get bigger and bigger and bigger and bigger, which then tells us that if we're taking the log of a very small number, it's going to be really small, a really small negative number. So we're going to artificially induce some big errors, some big differences between the so-called actual data and the fitted line. And that's going to, by putting in those small numbers in the place of the zeros, we can take a lot of them. We're going to tilt the line a lot, which is going to change our slope estimate a lot. So, got any other suggestions for what to do with these zeros? Right? That's what he just said.
How about take the...
But that tilts the line in the way that you want it. So is there a question? Well, there might be some other observations in here where the quantity of meat is 1, and 0 is not the same as 1. Consuming no meat is not the same as consuming a quarter-pound unit of meat. So I'm just telling you, you're trying to take the log of zeros. You do more damage by replacing the zeros by a very small number, or by adding 1 to everything. Adding 1 to everything is just going to shift the line up almost the same amount all the way along. Adding 1 to everything. So after you add 1 to everything, you end up producing, if the original data was scattered around this line, like that, and there are some observations where the quantity of meat was less than 1, but not 0. By adding 1 to everything, in effect what you do is you shift the line up, but the vertical shift gets smaller and smaller and smaller for big values of x. But you're doing less violence to the data than by just sticking in a little tiny number instead of a 0. And so you've got to be paying attention to what kind of transformations you're using in the data. And the effect that it's going to have on the least squared line. An alternative would be to fit a median regression, because in the median, it doesn't matter how big a mistake you make, only that the sign of the mistake be preserved through whatever transformation you use. So, for example, I've sent you a listing of everybody's numerical score on the exam. And I forget what the median was. I don't remember it. But suppose, just for the moment, that the median score in the class was 71. Would it make any difference if I realized that I had incorrectly graded Green's test and I added 2 points to it? She was above the median. So I incorrectly scored her test and I added 2 points. Would that change the median? Would it change the mean? Yeah. Okay, so a median regression won't be influenced by the size of the error that's made in the fitted values. As long as you're not shifting the point from one side of the line to the other, nothing will happen to the line. Okay, so... Sure. So you treat the zeros as a missing value?
Yes.
Well, one of the things that we say is that bigger is better. More data is better than less data. Right? And so more data is better than less. And the reason more data is better is because the estimator that uses more data is more efficient. And is efficient in a statistical sense. So we try to avoid throwing out data. There's information contained in those observations can have zeros for the quantity of meat consumed. And we don't want to throw away information.
What's the benefit of performing the zero number of 1?
We just decided we weren't going to just arbitrarily change only the zero values by 1. We were going to change everything by 1. Or change everything by the same number.
What's the benefit?
You have more data. Look how many zero observations there are. There are 1, 2, 3, 4. There are 4 or 5. Oh, wait a second. That's the whole data set. I guess there are 4. I guess there are 4 missing observations. There are only 30 data points. So you want to throw out 10% of your data? And it's perfect. If you figure out a way to use it, it's perfectly good information. There were some houses that didn't buy meat. And it's of interest to us to know why.
How much you add to that?
We're going to come to that later tonight. So Hohn's suggestion is that why don't we find some households. Here's a household that consumed no meat. They spent 40 shillings or 40 pence on bread. They spent nothing on meat. They had 4 people in the house. Their income was 69 pence. Okay? So Hohn's suggestion is maybe we could find another household in the sample that looked almost the same. And instead of find that missing household that was the same in every respect other than the quantity of meat consumed and replace the zero by the quantity of meat that was consumed by that other house that looked otherwise identical. That's a pretty good idea, and actually that raises an interest. The fact that you asked that question reminded me of another discussion that we could have at one point. So Hohn's suggestion was that we find households that are similar to the ones that didn't consume anything and try and impute what that house should have done. So his argument is perhaps that maybe the zero was misreported data or missing data. So I'm not entirely convinced. I think here a zero is a zero. But it's another approach that you could take, and we'll see what the statistical consequences of Hohn's approach are in a little while. The kind of stuff that's done by Kruger and Card and Angress is a lot more sophisticated than the simple description that I gave you. So let's close the data. So family size and income fit these log-log models and test the hypothesis that family size and income both increase by the same proportion and bread and meat consumption increase by the same proportion. That is, the demand for bread and meat are homogeneous of degree 1 in family and income, food for both bread and meat, and the answer were. There's the results for bread. Do not reject the null hypothesis, so the demand for bread is homogeneous of degree 1. And demand for meat is also homogeneous in degree 1 in family size and income. Okay, so that was a little problem set. But that they're homogeneous in degree 1, and we failed to reject them.
What thing is this file?
It's here in the syllabus. hypothesis testing, bread and meat.
Right.
Get the data, get the meat.
How much we?
Yeah, I've been thinking about it over the last week or so. I would like to put together another data set, another problem set like that bread and meat one. I really like that. Conquer still uses that one also. I talk to him from time to time, and I look at his website, and he still has his students doing it 30 years later. Great problem set.